Hello student, how are you all? Okay, fine. I think that all you have celebrated many festivals. Okay, now come to the point. We have the new topic related your chapters. Okay, that is the force on charge moving in magnetic field. It means whenever you know that the charge will move inside a magnetic field, on that case we can find out how much force will experience. Is it clear? Okay, very good. But before it, you know that suppose we have you can see these ones in a coordinate frame we have already discussed now, x-axis, y-axis and z-axis. Okay, very good. So suppose that we have a coordinate frame. This is the x-axis, this is the y-axis and this is the z-axis. Okay, very good. And suppose that the magnetic fields B is the magnetic fields which acts along the y-axis and F is the force experience along z-axis. Okay, and suppose the charge having velocity v is the velocity and here is the angle theta, and suppose the charge plus q is moves in the magnetic field. Okay, on that case what you will assume, suppose that this you will take either, also you can take this is the theta. Okay, you can join this one if you will join here like that. Okay, and also you can join here, suppose that this step all the axes you can join. Okay, so we have your coordinate frame x-axis, y-axis and z-axis. Along the y-axis here is magnetic field B which acts, okay, perpendiculars, and this is the velocity, okay, through which the charge moves in the magnetic fields, and here is the v sin theta. This is the components of the magnetic fields. Okay, so whenever the charge will moves in a magnetic field, or you can say that the considers, you can assume that when the charge will moves in the magnetic fields, okay, so force will experience and it will depends on the following factors. So what is the factors? First, you know that the force will depends or it will directly proportional to the strength of magnetic fields. Another, it will also, okay, depends on the components, and one more is the charge. It will depends because the force will depends on the charge also. So these are the factors that we can write. Means suppose that let us consider charge is moving in a magnetic field due to which it experiences force, and it depends on following factors. What is the factors? You know, the directly proportional to magnitude of, okay, first directly proportional to magnitude of a strength of magnetic field. A strength of magnetic field means, you know, F is directly proportional B. Very good. F is directly proportional to B. You can put this is the equation 1, because when the force will experience, So F will directly proportional to B. Is it clear? And another you can also write that directly proportional to magnitude of charge. Also directly proportional to magnitude of charge. That means F directly proportional Q. Okay, put this is the equation 2. Now there is the two equations, and you know that when the charge will move, so it will also depends on the strength of what components of. Okay, so you will also write the directly proportional to component of velocity. Okay, directly proportional to the component of the what velocity. Okay, component of the velocity of which one? Velocity along the direction. Okay, velocity along perpendicular also, along perpendicular to the direction. Okay, which perpendicular to the direction of magnetic field, direction of magnetic field. Now student, that you can write, that is F directly proportional V sin theta. Okay, now you put this is the equation 3rd. Okay, according to this movement of the charge, we have three equations. One is the first we have written directly proportional to magnitude of a strength of magnetic field, that is F directly proportional B. Another we have directly proportional to magnitude of charge, that is F directly proportional Q. And one more is there, directly proportional to component of the velocity along perpendicular to direction of the field, that is F directly proportional V sin theta. Okay, now we have three equations, we can combine this one. Very good. Now combining equation 1, 2 and 3rd. Now if you will combine, then you will write, and all having the F, so you will write F, and all having the proportionality, write proportionality, then BQV sin theta. And you know that whenever you will remove this proportionality, so or you can write F is equal to K BQV sin theta. Can we write? Where you will write here, where K is proportionality. Okay, proportionality constant. I have written where K is proportionality constant. It means in SI units K is equal to 1, therefore F is equal to BQV sin theta. Okay students, so this is the force that you got. You can also write in the vector forms or in vector form. Okay, what you will write? You will write this one, F equal to, vector F equal to, okay, you can write Q into V cross B. Okay, because whenever you will write in the vector form, so sin theta will removes, at the place of this here will be vector sign. So we got the formula F is equal to Q into V cross B. This is the first experience on charge when it, okay, moving in magnetic fields. Magnetic field, already you know that we have already discussed the magnetic field and how it can experience the force. Okay, and a special case also you can find out. How you will find out the special cases? Suppose that when charge particle, okay, if the charge particle will rest, then what will happen? This side I can erase. I think that mostly all you have written, and those who have not written, please you can take captures. Okay students, and till now those who have not subscribed, please subscribe my channels, and also press the bell buttons, because whenever I will upload the new video, you will get the informations. Is that clear? You will get the notifications, and also like, and after completing this one, share in the group. Okay students, thank you. Now come to another related this topic. What is, I told that we can find out there, what you will find out, a special cases. Okay, so you can take the a special cases. How you will find out what is the special cases? Suppose that when charge particle is raised. Okay, when the charge particle is in rest. Okay, rest, that means what? That is v is equal to 0. Therefore, you have formula F equal to B Q V sin theta. Then put here B Q into 0 into sin theta. So multiply with the 0, that you will write 0. It means force will 0. No velocity, then force will 0. Okay, but you know that whenever the charge particles moves parallel, okay, when the charge particle moves parallel, second you can take, when the charge particles will move parallel to the magnetic field. Okay, it means theta will what? 0 degree or either 180. Therefore, F equal to BQV sin 0 degree. BQV sin 0. Why? Because theta is equal to 0. So therefore F is equal to BQV. What is the value of sin 0? 0. Very good. So here will be 0. It means F equal to 0. Here also the force will 0. If you will take theta is equal to 180. If you will take theta is equal to 180. Therefore F is equal to BQV sin 180. It means F is equal to BQV into 0 means 0. Means whenever it will parallel, then the force will 0 in both case, parallel or anti-parallel. Okay, it means the force will 0. Why? Because theta is equal to 0. So sin 0 0. 180 here is also 0. And one more case you can take, students, when the charge particle, okay, when the charge particles moves perpendicular to magnetic field. One more case you can take. Suppose that thirds, when the charge particles moves perpendicular to the magnetic field. Okay, that is the theta is equal to 90. So what you will write here? You will write here F is equal to BQV sin 90 degree. F is equal to BQV sin 91. So F is equal to BQV. So this is the maximum. This is the maximum force. Okay, students. So thank you. I think that all you have written. Okay, and related this one, another topic we will discuss in the another. Okay, another day. Thank you.